A drug manufacturer forms tablets by compressing a granular material that contains the active ingredient and various fillers. The hardness of a sample from each batch of tablets produced is measured to control the compression process. The target value for the hardness is mu is equal to 11.5. The hardness data for a random sample of 20 tablets are, so here's our data. Is there significant evidence at the 5% level that the mean hardness of the tablets differs from the target value? Carry out an appropriate test to support your answer. So, we want to perform a test of the null hypothesis, which is the mean is 11.5, versus the alternate hypothesis, being the mean is not 11.5, where mu is the actual mean hardness of the tablets. We will perform the test at the alpha equals 0.05 significance level. So let's go ahead and do our plan. So if conditions are met, we should do a one sample t-test for the population mean. The reason why we're doing a t-test is because we don't have more than 30 data points from our sample, and we don't know the population standard deviation, right? So remember, if we have the sample size is at least 15, we use the T procedure, or the T procedure can be used except in the presence of outliers or strong skewness. So let's go ahead and check our if there are any outliers or strong skewness. So let's go ahead and do our one variable statistics of the data. I have already put in the data for this problem. So now let's go ahead and do menu, statistics, stat calculation, one variable statistics. We want our results in the B column, and there we go. So X bar is 11.516. The standard deviation is 0.094955. Quartile 1 is 11.46. The median is 11.5. Quartile 3 is 11.59. And the max is 11.715. All right, so let's go back to our problem and put in all of that information. So it was 11.516 for the mean. For the standard deviation, it was 0.095. The minimum is 11.36. Quartile 1 was 11.461. The median was 11.501. Quartile 3 was 11.597. And the maximum was 11.715. So let's go ahead and do our outlier test. So for outliers on the left of the data, we'll do quartile 1 minus 1.5 IQR. So that's equal to 11. Let me scoot it up so we can see. 11.461 minus 1.5 times quartile 3, which is 11.597, minus quartile 1, which is 11.461. And this is equal to 11.257, which is less than the minimum. So, no outliers on the left side of the data. Now let's check the right side. All right, so that's going to be 11.597 plus 1.5 times 11.597 minus 11.461, right? And this is equal to 11.801, which is bigger than the max. So there are no outliers on the right either. So this implies there are no outliers. All right, so now let's check if the skewness is significant or not. Okay, so remember, X bar was 11.516. The median was 11.501, and the standard deviation was 0.095. So we know that X bar is bigger than the mean, so that implies that there is right skewness, right? but we'll check to see if it's significant enough to be worried about it. So we're going to do our test. X bar minus 0.5 times the sample standard deviation, and X bar plus 0.5 the standard deviation. This is equal to 11.516 minus 0.5 times 0.095, and then 11.516 plus 0.5 times 0.095. And this gives us the interval 11.4685 to 11.5635. All right, so we can see that M is equal to 11.501, which is contained in this interval, right? Which is contained in the interval 11.4685 to 11.5635. So we can write the median is within 1/2 a standard deviation from the mean. So the right skewness is only slight. All right. So this means we know the distribution is normal enough, right? So the distribution is close to normal. All right, so now let's check our independence. So independent, or our 10% condition. Okay, so N was equal to 20 tablets, right? And N is all possible tablets produced. Right, let's make sure. Back to ingredients. Yeah. Compressed granule drug manufacturer. So produced at this drug manufacturer, right? At this drug manufacturer. Oh. All right. So clearly we have our inequality. N is less than or equal to 1/10 of big N. That means 20 is less than or equal to 1/10 of N. And surely 200 is less than or equal to, the number of tablets produced at this drug manufacturer is bigger than or equal to 200. So that means all conditions are met. So now we can do our test statistic. All right, so X bar, remember, was equal to 11.516, and the standard deviation was 0.095. So our test statistic is 11.516 minus, so our null hypothesis was that 11.5 over the standard deviation, the sample standard deviation was 0.095 over the square root of 20. And this gives us 0.772. All right, so now we need to find our t-value, or our probabilities that correspond with that t-value. Since this is a two-tailed test, we can see the degree of freedom is equal to 20 minus 1, which is 19. And let's go ahead and go to our table. Okay, so it was 19. Oh, let's go here. So 19, and it was 0.7. So it was between this one and this one, right? So it's between 0.2 and 0.25. So let's go back. But since this is a two-tailed test, we have to take into account the area of both these sides, right? So this is only what the table tells us is only the area of one tail. So we have to have the area of both tails, right? So we need to do 2 times, so remember it was 0.20, and then 2 times 0.25, since this is a two-tailed test. So this means that the p-value is between 0.40 and 0.50, which of course this implies that the p-value is bigger than alpha, which is 0.05 by a long shot, right? So since our p-value is bigger than alpha, which is equal to 0.05, we have to fail to reject H naught because it's not in our rejection regions, right? So we do not have enough evidence to conclude that the hardness of these tablets is something other than 11.5.